All right, so you'll find today's lesson in Google Classroom. I thought I remember putting there. Yep. Week 18, number 1. So phase change lesson 3, go ahead and click the Nearpod. All right, so in our last lesson, we learned about 3 claims. Those were the 3 claims I just talked about, made by different forum users. Remember, those were claims that were submitted to Titan Fan 5's question, okay? And those claims were answers to his question. Brody, are you good or you need help getting there?
No, yeah.
You got there? Okay. So those are answers to his question. So you chose the claim that you thought was best supported by evidence. And these were our 3 claims. I just went over them in the review. Claim 1, I think the molecules in a substance disappear or no longer exist when a substance changes phase. And they thought that because when the substance goes from a liquid to a gas, they can no longer see those molecules. Claim 2 said that they move differently. And they thought that because when they tilted the container, the liquid, the gas, and the solid did not move in the same way. Claim 3 thought it changed to a whole new molecule because they thought on the macro level, the liquid, the solid, and the gas look so differently, so the molecules must be different. Those were the 3 claims. In scientific argumentation, you can also use evidence to go against or what we call refute claims that you do not think are well supported. The word refute, it will be important when we make and analyze arguments, and it means to provide evidence that goes against a claim. So we're so often used to providing evidence to support a claim. You can also use evidence to go against a claim. Scientists refute claims with evidence by sometimes the evidence can be used to go against. Refuting the evidence may show how an aspect of that claim is not possible. And at some point, scientists may decide to eliminate or get rid of a claim if the refuting evidence is strong enough. However, ideas may change as new evidence is gathered. So we're going to continue to collect evidence to support or go against these 3 claims in this lesson and in the next. Remember, the question was, what happens to the molecules of a substance when it changes phase? Again, claim 1, they disappear. Claim 2, they move differently. Claim 3, they turn into something totally new. So today you're going to read an article from the article set, Weird Water Events. And the article is going to help you to collect evidence to either support or refute one of the forum users' claims. So you're looking for evidence for those 3 claims. Today's reading contains a set of articles. You're going to read chapter 1, Weird Water, plus 1 more of the articles in the set. They're very short, so it's like a book, but a very short book. There's different chapters. So you're going to read chapter 1, and then you're going to pick 1 other chapter to read. Don't get stressed on the word chapter. They're short. They're just a couple paragraphs, okay? It's not like pages and pages. Remember, we use active reading, so we are going to be annotating as we read. We want to focus on what we're learning. We want to be asking questions. We want to be thinking about making connections to things that we know, questioning things that we don't know, really paying attention to what it is that you're reading. And we have some examples of annotations from Brianna. She read the Weird Water article, and these were some of the annotations that she made. So by looking at her annotations, we're going to learn more about how to do that. I know you know how to do that, so we're going to do that rather quickly. Go ahead and at the bottom of your screen there, click the lesson 1.4 activity 2. That is going to take you to Amplify. You need to log in. Once you get in and get all loaded up, you're going to click this blue Weird Water Events link. So click the blue link. Does anybody need help getting there? Okay, so what we mean by chapters, if you look in the upper left-hand corner, you will see the book and you'll see these lines. If you click the lines, those are our chapters, okay? My video here is loading for a moment. So these lines are the chapters. And you're going to read number 1. Everybody reads and annotates 1. And then you choose either 2, 3, 4, or 5. You do not do them all, you pick 1. So you read the first one and then choose one of the next ones. You guys are going to stay here on the article. I'm going to go back to the Nearpod. So the first thing you always want to do is read the chapter of the what you're reading. And we are reading number 1, Weird Water. So Weird Water is kind of a strange title, right? Why is water weird? What can be weird about water? So we're going to highlight the title, Weird Water. And we're going to note it with a question. So you're going to highlight Weird Water. And if you have your own question, that's great. If not, we can use Brianna's question. And her question was, what is weird about water? Okay. So you highlight, go back, click note. What is weird about water? Oh my gosh, I'm a mess up here. Perfect. So you want to be asking questions. Then you want to read chunks, okay? You don't want to read a sentence, annotate. You want to read chunks. So if you read the first paragraph, water is amazing stuff, and it does some amazing things. It flows, it sparkles like diamonds, and it seems to appear and disappear like magic. These are all larger scale observations of water's appearance that we can make with the human eye. We can also think about water in all substances on another scale that we cannot usually see, the molecular scale. Molecules are too tiny to see, but they are very important. Water is made of molecules, and so is almost everything else on Earth. The appearance of water is determined by the way the water molecules are moving. So after you read the first paragraph, you want to kind of think about what it is that you've read, any connections that you can make, anything that may have confused you. So Brianna thought that after reading the first paragraph, it was difficult for her to visualize how the water molecules move since she can't see them. But then she remembered using the sim, where she learned that the molecules in different substances do not move in the same way. Each of them moved very differently. She also remembered that she needed to push herself to make a connection that she wrote was meaningful and deep. So she wanted it to be a little bit deeper than just molecules move. So she selected the very last phrase of that paragraph where it says the water molecules are moving. So if you have a different one you want to select, that's fine. But if you want to use Brianna's, that's good too. So select that last phrase, highlight it, And the note that she made was in the sim, the way the molecules moved varied and changed when we changed the phases for each substance. Okay, and if I went too fast for you, you can look back at the Nearpod, and it's right on there on your Nearpod screen. And go ahead and save your note. Second paragraph, you might think of water as a liquid, but water can actually exist in 3 different phases: liquid water, solid ice, and a gas called water vapor. No matter what phase water is in, the water is still made of the same molecules. They just move differently. Brianna thought there was a diagram at the start of the text that I think relates to the second paragraph, which describes each phase of water. So go ahead in your article and scroll back up to that diagram. So here's the diagram that she's talking about. And she decided to record her questions about the diagram so she could discuss them later or think about them at the end. So the note that she added about the diagram, so you want to select the diagram. And what does this diagram show? How does it relate to the text? And once I'm typing on the wrong one. Once I set you off on your own, I want you to go back and I want you to really dig into this diagram and try to figure out what it is showing. All right. Again, if you need that, it's on the Nearpod. Is everyone good? All right, so you're going to use the active reading guidelines today to help you with the rest of the article. Think carefully about what you read, pay attention, annotate, highlight challenging words, questions, connections, and look at all the pictures carefully. Like I said, I want you to go back to that diagram and really dig in. Look at the pictures, read the captions, try to get a better understanding about what's happening on that molecular level. So, in case you didn't get the directions, you're going to read and annotate chapter 1, Weird Water, and then you're going to pick another article to read and annotate. Do not do all of them. Just pick number 1 and then another one. Your annotations will be graded after your second read. That's how I always do it. So you won't turn anything in today, but after we do our second read, which will be tomorrow, then you'll turn them in and I'll grade annotations from today and tomorrow. Okay, does anybody have any questions? All right, you can go ahead and work on the remainder of that article. If you finish early, you can do Quizlet or missing assignments.